Our primary concentration is on nursing homes for the elderly and senior citizens to assist them in managing their daily requirements, utilizing our device reminders and prompts. This video focuses on the products we offer.
So here we'll be seeing a small demo about a project. The basic parts consists of two. There are two main blocks. The first block is for scheduling. So we'll be having a basic input form. Input form is where we'll be giving the medicine name, the medicine time, and the medicine date. So this form will be directly connected to the cloud. The cloud database name is medicine. So this is directly connected to the IBM Cloudant DB. Now, since we are inserting the values, we'll be using this insert operation. And then there's another function. This function is basically used to reset the form to its original values because we need to add more than one medicine. So we're using this function. And this function renders the time of insertion. So it is just a function to get the time. And it just stores the medicine name and in the form of ID and name. So the name consists of the message payload name, which is the medicine name, and its ID is being stored. The ID is basically the combination of the date and the time together. And then we'll be giving a small delay. And message payload is used to display the output in the debug window. So this is the basic part, the first part. Now we have the second part is this code block. So this code block is used for comparing the time. So this is the main key block of the entire project. Firstly, we'll be using this function, which is used to compare the present time with the scheduled time. So this is the basic function, and then for getting the scheduled time, like the time which is we've been given, we'll be using this function to retrieve that medicine time and the date from the cloud. So we are getting the medicine from the medicine database, and we are searching the scheduled time using the ID. So this ID is what we've already used in the previous function for combining both the date and time. So we are just searching the medicine name by using the ID, which is date and time. Moving on to the next block. This block is just used to render the medicine name at the time which is been scheduled. So at this particular time, the medicine's name will be got using this function. And then it has been split into three parts for displaying the output. The first part is that we are displaying the output in the debug window by using the message.payload. And then we are using text to speech, like we are converting the speech text in the message, which is the medicine name, to speech. For that, initially the text is in a JSON format, so you have to convert it into string because the IBM text-to-speech service only recognizes string. So we are converting this JSON text to string using the stringify key function. So we're just gonna give please take and that medicine name. So this is what it should be read by this text-to-speech. And we're playing the output in the form of a play audio block. It's just been configured. And then the third part is that we have configured this to this IBM IoT, which is IBM IoT Watson. Moving on to the IBM Watson, here I've created a new device known as ESP32. So this device I've configured here in this IBM IoT node using that credentials like the API key and the token. So this ESP32 is what seen here. So I've connected the device with this node RED. So this is the overall flow. Now we'll move on how to schedule the basic timer. So this is the actual demo.
Okay, now coming on to the actual working of how it works. So first of all, this UI, it's a Node Red UI. So we have created this UI using Node Red. So where people or users or even patients, they enter the details like a medicine name, the time, and also the date. So for an example, we are doing with medicine name, which is Dolo 650. The time is like we'll do it 5 minutes later, so it's like 21 4, and now the date is 15 November 2022. Yeah, so you are gonna like submit it. After submitting this, Now we are coming to the the node RED, where we have entered the details. So in the debug window, the details are showed in the the debug window, with the JSON data like $650, the time, the date. So all the informations are kind of processed through the node RED. Now coming on to the actual simulation, so here's the ESP32. So the ESP32 is kind of connected to an IBM Watson platform. So here we have created an IoT device called ESP32, and we are kind of, as you can see, this is the kind of information about this IoT device, and we are kind of linking the IoT device to this ESP32, which is using the tokens and the credentials given by the IBM IoT Watson platform. So we are going to wait, until the request is kind of sent from the the node RED at the correct time for the patients to take the medicines. Once the correct time comes, the medicines to be taken will be sort of displayed, will be notified in the ESP32, which is always listening at the right time, and it will show. So as you can see, this is the Cloudant DB database, Cloudant DB, where every information or the data that store in the UI, it will get through the node RED, and it will kind of make connected to the Cloudant DB. So as you can see, there's a table of values, which is 20, 22, then 9, and there is also a different format for displaying the data, which is ID. The ID consists of the date, and the name, and so on and so forth. Yeah, as you can see, date and time here. So like there are like different types of formats for showing this different types of data. For visualizing, we are like showing the table of values and also the JSON data, which is the key value pair. So as you can see, we have successfully document saved. And yeah, coming on to here, this is the node RED that was explained earlier before now. So we are going to wait until the correct time, which is 21.4 comes. So when 21.4 comes, the IoT device gets notified, and also the text to speech also gets notified, and the you know it also the audio is also played that you should take Zolo 650 at that particular point of time. So these are the interfaces that we have done. So the time that I have given is 9:04, which is 21:04. So when the time comes, the debug window will be notified, and also the audio file will be playing using the text to speech.
Please take
So,
Dolo 650.
okay, the time now is 21:04, and as you can see, the medicine name, the time, and the date
Please
has
take
been
Dolo
displayed on the
650.
debug window, and then the text is also successfully converted into the speech. And on the
Please take
walk
Dolo
window,
650.
you will get the medicine name displayed on the LCD screen, as you can see over here.
Please take Dolo 650.
And also the LED glows as an indication.
Please take Dolo 650.
So this is the overall demo of a project.
Our future scope includes to create an app which is called as a medicinal caretakers, in short MEDI, which is a central part of the system. The prescription details, just a medicine intake time, pill count, compartment number, are inputted into the app. The app is connected to the IBM Cloud database. The wristband, which consisting of the vibrating motor, is integrated with a dispenser, which consists of the Wi-Fi transceiver module, LEDs, RFID reader with the help of Node-RED. When it's time for the patient to take the pill, the app simultaneously sends two signals, one to the pill dispenser and the other to the wristband. In the wristband section, the Wi-Fi transfer receiver module receives the signal from the cloud database and triggers the motor to vibrate. This allows the user to take the pill. In this pill dispenser section, the Wi-Fi transfer receiver module receives the signal from the cloud database and illuminates the respective compartment, which enables the user to identify the current pill compartment. All these operations are centrally managed and displayed in the mobile app with the integration of IBM Cloud and Node-RED. So to conclude, our mission's goal is to see how successful we are to develop a project based on the abstract personal assistant for seniors who are self-reliant will be in assisting individuals in better self-managing their medications. This includes betterment quality of life for individuals with chronic disabilities and their caregivers, improved ability to stay self-sufficient at home, social impact on the pharma sector, less dependency on healthcare and social services. We were also able to gain a lot of learning experiences by this project. These include creating an IBM Cloud, integration with the Node-RED platform, text-to-speech, IBM IoT platform, as well as MIT applications. Thank you.